Let's take a look at a couple of examples of DFAs. In the first one, we're going to consider bit sequences that contain 2 zeros in a row or 2 ones in a row. This means our alphabet is the set of the bits 0 and 1. As with all DFAs, we have to have a start state. So let's start there. Create a new state. I'll label it as a start state, and I'll indicate that it's a start state. Now, what I normally think about is what's going to happen when I'm in a particular state and I read one of the characters from the alphabet. So there are only two possibilities here. One is that I've read a 0, and the second is that I've read a 1. So let's imagine that I have read a 0. Well, that's getting me closer to having found the pattern of 2 zeros in a row. So let's introduce a new state showing that transition. So here I go from the start state on a 0 to a new state, and I'm going to label this state with a 0 to indicate I've just read a 0, and that's what gets me here. The second possibility from the start state is that I've read a 1. So let's introduce a new state that indicates that I've just read a 1, and I get there from the start state on 1 as an input. And I will label this particular state indicating that I've just read a 1. Now what I want to do is I want to think about what happens when I'm in each of these states and I read either a 0 or a 1. So if I read a 0 and I'm already in this state here, that means that I've seen 2 zeros in a row. That's actually a good thing, and it gets me to the final state. So let's introduce a new state, and its transition from here is going to be on a 0. And I'm not going to label it just yet because there's a second way of getting to this state. The second way of getting there is what happens if I'm in this state here and I read a 1. Well, that's also finding the pattern that I was looking for. There were two possibilities, either 2 zeros in a row or 2 ones in a row, and that will be a second way of getting to the final state. So that transition is on a 1. And so if I reach this state here, it means that I have either read 2 zeros in a row or 2 ones in a row. And so I'm going to label this as 0, 0 or 1, 1. And I'm going to indicate that this is a final state. The problem is I have to go back and consider what happens on other inputs in each of these states. So let's go back to this state here. I've just read a 0. If I read a second 0, that takes me to the final state. But what happens if I've read a 1? Well, I don't get to the final state in that situation because I wouldn't have seen 2 zeros in a row by that point. So I have, however, just read a 1, and I have a state that indicates I've just read a 1. So I'm going to make a transition from this state to the state that says I've just read a 1 on a 1. Similarly, if I've moved into this state here, that means I've just read a 1. If I read a second 1, that will take me to the final state. But if I read a 0 afterwards, immediately afterwards, then that's actually not finding the pattern that I'm looking for. But I have just read a 0, and I have a state that takes care of that for me. And that's this state up here. So I move on transition to this state on a 0. So that now takes care of all of the possibilities at the start, all of the possibilities after I've read a 0, and all of the possibilities after I've read a single 1. Now, we have to consider what happens after I've read 2 zeros or 2 ones. Well, at this point I've found the pattern I'm interested in finding, and I've reached the final state. But there could still be more bits to read in my string, and I have to take care of that. So what I'm going to do in this case is I'm going to have a transition from the final state on either a 0 or a 1 right back to this final state. So if I read a 0 after I've found the pattern of either 2 zeros or 2 ones in a row, I'm still in the final state. If I read a 1 after I found that pattern, I'm still in the final state. So notice that we can have a transition here that has two inputs on it. It's going to the same place. Let's check our DFA with a couple of input strings. Suppose we have an input string of 1010010. This is a string that contains the pattern 00 and should be accepted. So as we read each character from this string, we will move through our finite state machine. If we ever get to a point where we have no option, then we would reject the string. If by the time we get to the end of the string, we have landed in a final state, then we would accept this string. So we start off by reading a 1, and that takes us into the state labeled 1. Then we read a 0, that's going to move us into the state labeled 0. Then we read a 1, that takes us back into the state labeled 1. Then a 0, back to the 0 state. Then we read a second 0, and this is now moving us into the final state, but we still have 2 bits to read. So we need to read a 1, which keeps us in the final state, and then a second 1. And we see that this is actually a string that is accepted by our DFA. Let's take a look at a different example. Here we have a string 0101, and in this case, this string should not be accepted by the DFA because we don't see the pattern of 2 zeros or 2 ones in a row anywhere. So we start in the start state and read a 0, that takes us to the 0 state. Then we read a 1, that takes us to the 1 state. Then we read a 0, back to the 0 state. And then we read a 1. And we're stuck now because we have nowhere to go, we have no more characters to read, and we haven't ended up in a final state at this point. So this particular string is rejected.